Good morning. Welcome to the class 10. Today I am going to teach you chapter 2, Polynomial. Chapter 1, real number is the video of real number is uploaded by my fellow teacher. I am going to teach you the chapter 2, Polynomial. In the class 9th, we have already studied about the polynomial, but just for recall, let's see what is polynomial. Polynomial is the branch of algebra in which we use constants, any real number, variables represented by the alphabets A, B, C, D, etc. Basic signs plus, minus, multiply and divide. One more important thing in this one, power of variable used must be a whole number. This is the condition when an algebraic expression becomes polynomial. Means polynomial is an algebraic expression in which the variable used must having the exponent as non-negative integer. Be very careful. The power of the variable must be the non-negative integer. Means power will be the whole number. In the class 9th we have done to find the zeros of the polynomial. Zeros of the polynomial can be find out by common methods. Common method I mean by find their GCF, by for quadratic middle term splitting in a cubic polynomial by using remainder theorem, then again middle term splitting. In class 10 will especially the focus on biquadratic. Biquadratic polynomial, its general form is ax power 4 plus bx cube plus cx square plus dx plus e. This is biquadratic polynomial. In biquadratic polynomial, most of the time you will have given two zeros and we'll have to find next two zeros. When two zeros are given, find out their factors, multiply them. This will give you a quadratic polynomial. When biquadratic polynomial divided by a quadratic polynomial, again it gives you quadratic polynomial. Quadratic polynomial further can be expressed as a product of again two factors by using middle term splitting. Means these two factors are given, These two can be found out by long division process and by no means by middle term splitting of the quotient. If only one zero, in case if only one zeros of the biquadratic polynomial is given, then divide the given biquadratic formula polynomial by the first factor, you will get the cubic. And we have learned in 9th class how to find the zeros of a cubic polynomial. Here we have to find out the verification of zeros of polynomials. So first, see about the quadratic. General form is ax square plus bx plus c. Suppose alpha and beta are two zeros, then sum of zeros, they are also known as roots. Sum of zeros is alpha plus beta, it must be equal to minus b upon a. This is the first verification or relationship of the zeros of the polynomial. And product of zeros equal to alpha into beta, that must be equal to c upon a. This is known as S and this is known as P. These are the verification of the zeros of a quadratic polynomial. Now we have to see the verification of cubic polynomial. The general form of the cubic polynomial is ax cube plus bx square plus cx plus d. This is general form of the cubic polynomial. If alpha, beta and gamma are three zeros of the given cubic polynomial, then the verification of the zeros with the polynomial can be expressed as again by sum of zeros equal to alpha plus beta plus gamma equal to minus b upon a. SP, sum of products equal to alpha beta plus beta gamma plus gamma alpha, it must be equal to c upon a. And the product of zeros equal to alpha into beta into gamma equal to minus d upon a. So these are the relationship of the zeros of a cubic polynomial. Now we have to see if the zeros are given, then how to form the polynomial. If alpha and beta are two zeros of a quadratic polynomial, then new quadratic polynomial equal to k times of x square minus sx plus p, where k is constant, s equal to alpha plus beta and p equal to alpha into beta. So if alpha beta the zeros are given, then we can find out the polynomial whose zeros are given. Now see for the cubic, the general form of the cubic is ax cube plus bx square plus cx plus d. If alpha, beta, gamma, three zeros are given, then the new cubic polynomial equal to k times of x cube minus sx square plus spx minus p. Again, k is the constant. S equal to alpha plus beta plus gamma. Sp equal to alpha beta plus beta gamma plus gamma alpha, and p equal to alpha into beta into gamma. By this formula or expression, we can prepare a new cubic polynomial when three of the zeros are given. So this is the relationship of the zeros with their respective polynomial. Now we have to see how to find the zeros of cubic polynomial. The general form of the cubic polynomial is ax cube plus bx square plus cx plus d. To find the zeros or to find the factor of a cubic polynomial, first we have to use remainder or factor theorem, in which we'll have to put the values of x equal to plus minus 1, x equal to plus minus 2, x equal to plus minus 3, and so on. If we put x equal to 1 and the value of the polynomial becomes 0, then the x minus 1 will be the first factor. If p1 equal to 0, then x minus 1 is the factor. If p minus 1 equal to 0, then x plus 1 will be the factor. If p2 equal to 0, then x minus 2 will be the factor, and so on. By getting the first factor by using this process, we have to divide our cubic polynomial by long division process. Cubic polynomial, when divided by the first factor, we will get here the quadratic polynomial. When a cubic polynomial is divided by the linear polynomial, we will get the quadratic polynomial. In quadratic polynomial, we can use again the middle term splitting, and we will get again two factors. By this process, we can factorize a cubic polynomial. The graph of the biquadratic polynomial is of the form or means biquadratic polynomial 4 times 1, 2, 3, 4. 1, 2, 3, 4. So these are the shape of the graph of the polynomials. Let us recall the graph of the quadratic polynomial is of the form parabolic. It can be upward or downward. If If they are not touching, not intersecting the x-axis, means the quadratic polynomial have imaginary zeros. But if the graph is touching or cutting the x-axis, then it will have the real zeros. The graph of the cubic polynomial intersect the x-axis 3 times. The graph of the biquadratic polynomial intersecting the x-axis 4 times. So these are the types of graph of the polynomials. Let us conclude the chapter by some remarkable points. A polynomial can have many terms but not infinite terms. Exponent of variables cannot be negative. The exponent of variable must be a whole number. Polynomial with only one constant is called constant polynomial. The degree of non-zero constant polynomial is 0. Degree of a zero polynomial is not defined. Remind it. Keep in your mind. Degree of a zero polynomial is not defined.